So we're going to jump in. Thank you all for joining today. I'm really excited about this webinar. I'm Kate Stoll, Project Director for the Center for Scientific Evidence and Public Issues, or the EPI Center. Our mission is to build trusted relationships between experts and decision makers at all levels of government, with the goal of making it easier for policymakers to access and incorporate scientific information into their decision-making processes. And we're proud to be part of the American Association for the Advancement of Science, or AAAS, which is the world's largest general science society. Quick note, this event will be recorded and it will be posted. The recording will be posted on our event page at the AAAS EPI Center. We'll give that link at the end. And the reason I'm so excited about this webinar is because we have two amazing speakers today. Joshua Martin, the Chief Data Officer for the state of Indiana, is going to talk about uses of AI in state government and Indiana's policy governing AI use by state agencies. And Sayesh Kapoor of Princeton University is going to discuss the differences between 3 types of AI technologies. And guess what? It's not just generative AI. There's lots of different kinds of AI. But to get us started, I want to do a quick audience poll. So if Joanna will pull that up for us, we just want to get a sense of how familiar folks are with AI generally. And I'll give you a minute to respond to that. And while that's going, I want to ask in advance for your participation in our survey at the end of today's convening. I promise it only takes like 2 or 3, maybe 4 minutes to complete. It's anonymous, and your responses are so helpful for us to know if we're meeting your informational needs. So towards the end of the webinar, the link will be put in the chat, and it will also appear when the webinar ends at 3:15. So I want to thank you in advance for filling that out. We really do value your input. All right, we're getting folks. Okay, why don't we go ahead and show the results of the poll. We have a bit of a distribution between some super AI experts, folks that are somewhat familiar, a little, and some not at all, and that makes perfect sense. I feel like all of us can learn more about AI. There's really so much there, such a complicated group of technologies to learn from. Awesome. Okay, well, let's dive right in. We're going to start with you, Sayesh, and let me give a brief introduction. Sayesh Kapoor is a Lawrence S. Rockefeller Graduate Prize Fellow in the University Center for Human Values and a computer science PhD candidate at Princeton University's Center for Information Technology Policy. He's co-author of the new book, AI Snake Oil, which separates the AI hype from the true advances. And the book is out now, so check it out. You can find it anywhere you buy books. And actually, the first chapter is online for free for anyone to read, which I highly recommend. His research examines the societal impacts of AI with a focus on reproducibility, transparency, and accountability in AI systems. He's got experience in academia and industry, including at Facebook, Columbia University, and the Swiss Federal Institute of Technology. And he was recognized with lots of different awards, but one that you might recognize is Time's inaugural list of the 100 most influential people in AI, and he was in the most recent list too. So we'll have time for audience questions at the end, but while Sayesh is presenting, I encourage you to start throwing your questions into the Q&A box and queue them up, and we'll try to get to as many of them as we can at the end. So with that, I'll hand it over to you, Sayesh.
Thank you so much for that wonderful introduction, Kate, and thank you so much for being here, everyone. I'm very happy to be here to talk to you all about what different types of AI we see in real-world use and why AI is not just one technology, but rather a group of related technologies. So over the next 20 to 25 minutes or so, I want to basically cover 4 different things, starting with what AI even is. So what do we mean when we use the term AI? Now, AI stands for artificial intelligence, but despite the decades-long history of this field has been going on for over 8 decades at this point, it's really hard to come up with an overarching definition of what AI really is. But I found it useful to think about AI in terms of 3 very loose criteria. These criteria are not mutually exclusive, they're not exhaustive, but they sort of give you a sense of what we mean when I use the term AI. The first criterion is AI is used to solve tasks that require some creative effort or some training for humans. So it might be a task that you might need some small amount of training to do. For example, these days we have text to image AI models. You can input a prompt and you can get an output of an image describing that prompt. So that's an example of an image created, which would otherwise have required creative effort for humans. A second criteria is that the behavior of the AI system is not directly specified by the developer. So in other words, it's not the case that every single action that the system takes is hard-coded by the developer. An example of such a system where the actions are hard-coded is a thermostat. You can set a thermostat at a specific temperature, and if the temperature goes up, the cooling turns on. If the temperature goes down, the heating turns on, and so on. We would not usually see this as an example of AI because the behavior is directly specified in the code by the developer. In contrast, for most AI systems today, we refer to AI that uses past data to learn patterns from that data and automatically come up with these rules. The third criteria is that there should be some flexibility in the inputs. So in other words, the tool must work for new or unseen examples and not just for examples that are already present in past data. So in other words, if you're creating an AI to, let's say, play chess, it should be able to generalize to new chess moves rather than just do well on moves it has already seen before. So these are sort of the three broad and overarching criteria, which sort of help us get a sense of what we mean when we use the term AI. Now, even within AI, there have been a lot of different types of techniques that people have used. But today, when people talk about AI, the main thing they're usually referring to is what we call machine learning. So machine learning is basically, or ML for short, is the technique to learn patterns from past data. So for example, today's image recognition systems are good enough that given enough photos of cats on the one hand, and enough photos of dogs on the other, we can train the system to distinguish between a photo of a new cat or a new dog. And I think this hilarious example sort of illustrates this phenomenon. On the slide here, you see a picture of Labradoodles and fried chicken. If someone asked this question to you in the abstract, you might think it's really easy to separate the two, but this picture shows it's probably not as simple. But it is indeed true that given today's state-of-the-art AI systems, they can indeed learn to distinguish between very similar looking images of dogs or Labradoodles as well as fried chicken. And if you think about the tools that have caught a lot of public attention recently, tools like ChatGPT, it's exactly the same phenomena that drives these tools as well. So you have a lot of labels for all of the data that you have, similar to the labels of dogs versus fried chicken. And the tool, in this case, ChatGPT, learns to predict based on these labels. So here's an example. Let's say there is a sentence, "What is your name?" available on some website on the internet. This sentence turns into 4 examples for the model to learn. The first example is, "What is your blank?" And the correct answer is name. The second example is, "What is blank your blank name?" And the correct answer is your. The third example is, "What blank your name?" And the correct answer is, and so on. What's really key to the functioning of tools like ChatGPT is that we do this for every single sentence that we can find on a large majority of the internet data. So we take data that has been generated over decades across multiple types of websites, including e-commerce and social media and people's blogs and so on. And that's what leads to ChatGPT or any other language model being able to output text in a convincing way. Now, one of the sort of secret tricks or secret things behind how ChatGPT actually works is that at any given point, all that the system is doing is predicting what the next word should be given a series of words. So let's say you ask ChatGPT a question. Every single point of time, what it really is doing is answering what the next word should be in response to the text you've already written. And it does this using all of this training data that has been trained on from all over the internet. So this was the first part of the talk where we sort of looked at very broadly what AI means and what machine learning means. But one of the most confusing things about AI, at least as far as I've seen in the last decade or so of working in this field, is that there are many different types of AI. And fundamentally, these different types of AI have very little in common beyond the fact that they are trained on data and the three sort of criteria that we use to define it. So if there is one thing that you take away from this talk, it is this. AI is an umbrella term. And while some types of AI have made rapid progress in the last decade, other types of AI have not really advanced very much at all. So an example of this is generative AI. Generative AI is tools that are used to generate, whether it's text or images, or as you can see on the right side here, even things like protein structures. So if you've been following the news recently, Google's AlphaFold, two of the lead authors, actually won the Nobel Prize in chemistry for Google's AlphaFold. On the left-hand side is an image. This was generated, again, using AI. So OpenAI has a model called DALL-E, and this image was generated just by typing in the prompt, an astronaut riding the horse on the moon. So generative AI has made massive progress in the last 10 years. It really is sort of a transformative technology. And one of the things that this results in is that the issues with generative AI arise precisely because it seems to work too well. So there are issues related to labor displacement when ChatGPT or tools like it are being used to replace the work of copy editors or translators or transcribers. And there are also issues related to misinformation or over-reliance because these tools don't work perfectly. And if you sort of blindly trust the outputs of these tools, then you're likely to be misled. So this is the first type of AI. A second type of AI, which is somewhat related to this, is AI used for perception. So this could include tasks like detecting what's in an image or detecting what's in a piece of audio. And this has actually been really impactful in many fields. So for example, on this image here on the slide, you can see perception AI being used to aid agriculture. It is sort of aiding farmers by providing analysis about what parts of their farm might need more water and so on. And it is doing this by using images of the farm. And once again, perception AI has made a lot of improvements in the last 2 decades. But this also comes with its own ethical issues. And I think one of the main ones that we've seen is perception AI being used for face recognition. Now, on its own, face recognition is just like a technology, but in the hands of an authoritarian government, for example, it can be used to enable mass surveillance. And in fact, we have seen the same technology that powers this positive application of AI in agriculture being used by authoritarian governments to monitor minority populations and so on. Excuse me. And so even with perception AI, the ethical issues are arising precisely because it seems to work too well in these areas. And we are seeing misuse, not just by authoritarian governments, by the way. I recently read this piece in the New York Times, where even in private spaces in the US, like the Madison Square Gardens, people were denied entry on the basis of their faces. So face recognition was used. In this case, it was used to look at lawyers who were filing legal cases against the Madison Square Gardens owners. And all lawyers at the law firms that worked at these firms, they were denied entry on this basis, even if they weren't the ones who were in these lawsuits. So we're seeing there are many sort of dubious applications that perception AI can also enable. Now, in contrast to both of these applications is predictive AI. So predictive AI is AI that's used to make predictions about individuals and then make extremely consequential decisions based on those predictions. So the slide here has 2 examples. On the left is HireVue, which is a company that claims to predict which job applicants would be good based just on a video interview as well as like a questionnaire. And this questionnaire consists of things like, do you keep your desk neat or untidy? And on this basis, the company claims to predict which candidates are suitable for a job. On the right-hand side is an example called Upstart, which describes itself as an AI lending marketplace. And so it automatically decides which loan applicants should be given a loan And it does this using thousands of features about people, thousands of data points. For example, where they went to school, what their education level is, what their salary is, and so on. Now, for a large number of applications for predictive AI, the ethical issues arise because these tools don't work as well as the developers claim. There are a lot of false positives when it comes to predicting the future, and we'll dive into all of that in a second. But this is like really distinct from the first two examples, which is generative and perception AI, where we have indeed made massive technical progress. In contrast, for predictive AI, we are largely relying on decades-old techniques to create these tools. We are relying on, in some cases, like almost 100-year-old techniques that are just regressions. But because these developers are selling these tools under the banner of AI, they're sort of misleading consumers or the purchasers of these tools into thinking that these tools actually have the latest advances or they actually can work as well as the developers claim. So this brings me to the third part of my talk, which is let's look at some of these exaggerated performance claims. Let's look at what's really going on when developers claim that their tools work very well. So we looked at an example of hiring automation earlier, which was HireView. Here's another example. This is a company called Retorio. It claims that using video interviews of candidates, it can identify which candidates should proceed further in a job interview. In other words, which CV should be seen by a recruiter versus automatically discarded. Now, in most cases, predictive AI goes unchallenged because people just don't have the time or expertise to assess these claims. But in Retorio's case, a group of investigative journalists sort of launched a deep dive into how the tool actually works. They tasked one of their reporters to sign up for these interviews. And in one case, the reporter basically gave an interview with a plain background. And then in another, he gave the same interview, in fact, he used the exact same video, but he just used an image of a bookshelf in the background. Here's what happened. So in the image on the left, there's no bookshelf. In the image on the right, there is just one additional bookshelf. As soon as you add a bookshelf to the background, the results of this candidate shot up. Now, this is clearly like a fluke. This is a statistical error in the sense that if a person is giving the exact same interview, then whether or not there's a bookshelf in the background shouldn't really influence the outcomes of this hiring tool. And yet this is exactly what these journalists found. In fact, this went one step further into the more problematic terrain of what happens when you add a piece of headgear, or what happens when someone has a lighter versus darker skin. And they found that in each of these cases, these tools amplified the biases of the system. So if you have a darker image versus a lighter one, you are less likely to get a higher score. If you're wearing a piece of headgear, you're less likely to get a higher score. And like, even if this example does not seem as compelling or as like life-changing, we have seen similar cases in extremely consequential situations. So in 2013, the country of Netherlands deployed an algorithm to detect welfare fraud. In particular, the country was trying to detect whether parents are fraudulently claiming child tax credits. The algorithm wrongly accused tens of thousands of families of incorrectly taking part in childcare fraud. And it took 6 years after the introduction of this algorithm for this to be recognized and the algorithm to be rolled back. During that time, many families were sort of basically like asked to pay back tens of thousands of euros, in some cases over 100,000 euros. And after the scandal was uncovered, the Dutch prime minister and his entire cabinet resigned, in part because of the uncovering of this algorithm. Now, this is not just the case outside the US. Even in the US, we found many consequential examples. So in 2017, the US healthcare technology company Epic launched an algorithm to detect sepsis in hospitals. Now, sepsis is one of the leading causes of death in US hospitals, and in fact, worldwide. So if we can predict sepsis with a high accuracy, that would indeed change how we administer healthcare. This algorithm was launched in 2017, and for 4 years, this algorithm was deployed in hundreds of hospitals across the country. The first time this algorithm's use was investigated was 4 years later, when it was found that as opposed to the accuracy claimed by the authors or by Epic, the authors had claimed that, the model has an 80% accuracy. The actual accuracy was around 60%. Now you can get 50% accuracy just by tossing a coin, right? And so this is not that much better than just flipping a coin at random. And so a year later, Epic discontinued this one-size-fits-all sepsis prediction model. It asked hospitals to train their own models, which is arguably a much better approach because you have data scientists in-house who can understand how the tool might be used, and they can understand how errors might creep in. And finally, we've also seen this in use, or we've also seen examples in US states where in 2018, Oregon implemented a child safety screening algorithm. But after widespread reports of bias against Black families, the tool's use was discontinued in 2022. Now, the key thing I want to point out, what connects all of these examples, is that all of these tools were examples of predictive AI. These were cases when we were making predictions about individual people and then using those predictions to make highly consequential decisions, such as whether someone committed fraud and needs to pay back tens of thousands of euros, whether a patient needs to be acted upon for sepsis, and whether a family needs to be investigated for child maltreatment. And it's not just in these three domains or in these three examples that predictive AI is being used. In the last few years, we have seen hundreds of such incidents across dozens of domains, including in education, in healthcare, in finance, and so on. And one of the key things we've realized through our research is that while AI can be used to understand collectives or aggregates, while AI can be very useful to point out overarching trends in the data, predictions about individual people are extremely hard. And this is especially the case when those predictions are then used to make extremely consequential decisions about people, such as whether or not someone gets a loan, or such as whether or not a family is committing child maltreatment. So why does this keep happening? Why do vendors keep getting away with selling all of these tools? So this brings me to the last part of my talk, which is how can we close this feedback loop of hype? I think one of the things we need to do is to understand that AI is not just one technology, but rather it's a group of related technologies, and not all of these technologies work as well. In particular, making predictions about people is extremely tenuous. Another thing that we can do to sort of start closing the feedback loop is to take reporting and take claims about how well AI can work with a grain of salt. So here's what I mean by that. In 2023, Microsoft released its Bing chatbot. This was a replacement or an addition to their traditional search bar. And after this was released, we had a lot of news reporting on AI. All of this reporting sort of anthropomorphized AI. So anthropomorphism is when you attribute human-like characteristics to systems or tools that are non-human. For example, the New York Times called this Bing's AI chat says, "I want to be alive." The Washington Post said, the new Bing told a reporter it can feel or think things. And the list goes on and on. Someone even said, our AI chatbot's turning sentient. Now, what all of these headlines do as a result of looking at all of these headlines, people are misled into thinking AI is a lot more than it is. And I think the real tragedy is that we've known this effect that AI has on people for over 6 decades at this point. So here's an example of an experiment that took place in 1966, when Joseph Weizenbaum constructed a chatbot called Eliza. Eliza was a very simple chatbot. It would basically just parrot back the user's sort of comments and ask a question based on it. So for example, Eliza would start with something like, "Is something troubling you?" And someone would respond, "Men are all alike." Eliza would just say, like a random parroted question, "What is the connection, do you suppose?" And so on and so forth. And the conversation would continue. The key thing, though, is that when people actually started using this chatbot, a lot of people refused to believe that this was a chatbot and not a human talking to them. So this was termed the Eliza effect, that is, our tendency to attribute humanness to things that are not really human. And we've known of this effect for the last 6 decades. So instead of informing people about how they can interact with these tools and how not to misattribute humanness or agency onto these tools. I think it's really unfortunate that media organizations reporting on AI as a whole have sort of leaned into sort of further anthropomorphizing AI by asking questions like, are these chatbots turning sentient? So this is just one example of how news media can mislead people. There are multiple other examples. For example, you'll often see images of robots accompanying articles about AI. So this is one I randomly picked up from CNN. And in most cases when images of robots accompany a news article, the advances being talked about actually have nothing to do with robotics. So in this case, I looked into the article, and the article basically was talking about something that's closer to an Excel spreadsheet rather than the Terminator. And what this does is sort of exploits our biases towards treating these systems as human-like. And I think this goes a step further when even the journalists who are trying their best to inform people about AI end up misinforming them. So here's an article that Michael Hilsick at the LA Times wrote. He was talking about some of our work in sort of busting the hype around AI. And in particular, he was talking about the fact that when images of robots accompany articles that have nothing to do with robots, that can mislead people. And yet this very same article also included an image of a robot. And this shows how sort of deep and widespread the concerns around getting people to click on news articles are. Unfortunately, these days, most journalists don't really have control over what the headline is or what cover images are used to accompany an article. And so this also points to a sort of deeper issue with journalism, which is that it has increasingly become reliant on clicks. It has become reliant on people seeing and clicking on the article and sharing it on social media. And because of this, because journalism's revenue sources have dried up, we are increasingly seeing a lot more clickbait when it comes to articles about AI. So to quickly wrap things up, how does AI hype persist? I think there are a number of reasons, and I think many parties are responsible. It's not just journalists. So companies and vendors, when they're selling AI tools, they conflate the different types of AI. They conflate predictive with generative AI. And AI research is unable to keep the industry accountable because AI research is also increasingly dependent on the industry. What this means is that most of the prominent results that we see about AI are exaggerated. And when we have uncritical reporting on AI, this feedback loop is completed because journalists are unable to perform the critical function of actually informing people about what the real state of affairs is. So how can we sort of correct these things? What can we focus on before deploying AI in the real world? I think there are many ways to start and many ways to do better. We'll see a lot of it in the next talk by Josh, but I want to go over some of them very briefly. The first is a focus on what's in the training data. So we began this talk by seeing that what AI can do is dictated in a large part by how it has been trained. And so even looking at what websites the data is trained on can really tell us a lot about, or what sources of data it's trained on can really tell us a lot about how well the system will work. In tools like ChatGPT, we should expect AI to work a lot better for information that's widely available on the internet, things on Wikipedia, for instance, compared to things that might not have been in the training data for the system at all. A second place where we see a big gap right now is people don't focus enough on evaluating the models. So here are two examples. On the left-hand side is an evaluation by a group of journalists of an existing algorithm that was already in use for predicting recidivism. So this was COMPAS. On the right-hand side is a screenshot of a more recent investigation of predictive policing software. In both of these cases, these journalists uncovered that the model worked far more poorly compared to what the developers had claimed. So just reevaluating the model on more recent data can tell us about how well the model seems to be working. Another place to look is when you're thinking about incorporating or purchasing AI vendors or purchasing from AI vendors or sort of incorporating an AI system, you can look at how past systems have sort of worked out or failed when they've tried to do similar things. And to do this, there are some very handy resources. One of them is called the AI Incident Database. So this basically collects news reports as well as other academic articles about how deployments of AI have gone wrong. And finally, one place to sort of safeguard real-world users from the harmful effects of AI is to provide mechanisms for contesting incorrect or flawed decisions. In most of the cases that we saw, predictive AI failed because the users had no agency. And so the decisions taken about them were basically taken without their consent, and they had nowhere to turn to if they wanted to sort of challenge the decisions or contest it. So providing mechanisms in place to contest these incorrect decisions is key. All right, so I'll end my slides here. I'm very much looking forward to hearing from Josh, as well as to all of your questions.
Thanks so much, Sash. Always so insightful, very, very helpful. So just remind folks, if you have questions, throw them in the Q&A box. Thank you, Peter, for starting out some questions in the chat, and we will get to that after we hear from Josh. So let me introduce Josh Martin, who's Indiana's Chief Data Officer and Executive Director of the Indiana Management Performance Hub. He has over a dozen years of experience in state government with a focus on data-driven governance. Josh was a leader in the development of Indiana's state agency AI implementation policy in early 2024, which he'll talk about today. And Josh was recognized for his leadership in the 2024 Global Top 100 Innovators in Data and Analytics report by Corinium. And prior to his current role, he honed his skills in international affairs and public safety. He holds a BA in political science and law and society from Purdue University, and a Master of Public Affairs from Indiana University's School of Public and Environmental Affairs. So Josh, excited to hear about your work in Indiana. So I'll hand it over to you now.
Hey, thanks so much for the introduction. And Sash, what a way to tee this up, to start thinking more critically about AI and the applications of it, and kind of the false promises that we keep seeing from different vendors, and the expanded capabilities that really aren't there. So we've had a very thoughtful approach to AI. Indiana is very fortunate to have had a large investment in technology back about 10 years ago to start building an agency that is focused on leveraging data as a strategic asset. So we've been bringing a lot of that historical data together from all of these disparate systems, knowing that we could be able to use that data in the future to help provide better citizen services. But that also comes with a huge caution sign on it. As Sayas was talking about, it gets really good remarks in the aggregate, but when you get down to the individual, there's a lot of challenges across recidivism, benefits, all of these different things that Sayas was talking about, where we've seen problems already in AI. So as it became very more prominent with ChatGPT becoming a very hot topic and generative AI becoming the new blockchain, which was a couple of years ago, the hype from all the vendors, we needed to get a common sense approach to what AI should look like, especially when we're looking at using it in government. We have a major responsibility in government to make sure that we're treating people fairly, that we're providing the best possible services to them, and that we're not doing any harm. So that's a lot to think about when you're putting in different technology platforms, when you're putting in different, analytical machine learning in there. And, even with some of the best data that you can get from historical systems, you're still bound by the limitations that those systems present from the way that they gathered that data initially. So there's so many different challenges that are there just based on the underlying data. And from our team's perspective, being able to work in that, we understand exactly how challenging it is. But we took a pretty proactive approach and launched an AI policy that was a very collaborative approach. We worked with all of our different state executive agency folks to get feedback as we were developing it. And it's really focused on being agile and pointing to some of the best practices. So it points to the NIST framework. which is going to continuously be updated and improved. And our policy is intended to continuously be upgraded and improved. And to not stifle innovation, to not stifle the way that we're looking at providing better services, but to be cautious, to move carefully and fix things rather than what some of the outside folks do is move quickly and break things. Um, so we put a readiness assessment on the front end of that because we want to make sure when our different agencies are going to get ready to go down a path that they know what the why is. You have to have a why. Why are you going to do this? We're not just putting AI in for the sake of AI. A lot of times you'll buy a product, AI is built in, it's going to do all these great things for you. But it's the why. Why are we doing it, and are we going to be able to get there and solve it? So one area where we've really started to push out a little farther is in our workforce recommendation engine. They call it Pivot. It's for unemployment insurance and those folks that are applying for unemployment insurance. It's trained on historic data that we know the data. So we know how it's trained and we know the limitations of that, but it's also an opt-in model. So people are given a disclaimer up front to tell them that this is AI. It's very early in its development. So it's not going to be the greatest things. It's not telling you what to do, but it's giving you options you might want to think about. And there's going to be feedback from it. And the data that you're putting in to apply for your unemployment insurance is all the data that we need. So it's not going to be a big extra lift. So if they click opting into yes for that, this will start to help predict what could be a good job for them, given their geospatial area, their background, where they've came from, all of these different artifacts on that. And say it's looking at other individuals that have been in similar situations that have had a better career after the fact. But if you're getting a recommendation, you lost your job, you apply for unemployment insurance, you used to work at a restaurant that didn't survive COVID, so now you're on unemployment insurance, and you're looking at this, and the area you happen to be in is very short on healthcare and specifically phlebotomists. So it's telling you should look at being a phlebotomist, but you really hate blood. It makes you queasy. You're going to pass out. Not a good recommendation for you. So they can provide that feedback that this is not good for me, and that will go back and help improve that information that's put in front of them in the future. But it is very much a decision that's made by an individual. There's a human in the loop. There's a human at the helm. So those are really important factors into the way that we've thought about deploying this AI, being careful with it. We actually went with an external assessment for the bias portions of things, and to make sure, one of the top experts when it comes to bias and false information coming from AI to come in and evaluate this to make sure that we're on the right path. And it's going to continue to be evaluated over time. I mean, Sash made such a really good point when it comes to you have to continue to reevaluate your model. You have to make sure that it is still doing what it was intended to get to that why. And if it's not, you have to continue to retrain it. So this isn't, hey, we do one big AI project and we launch it and it's done. And we say, yeah, that's great. There's day 2 support. There's day 500 support. There's still continuous things that you need to do to make sure that is doing what it was intended to do and it doesn't go off the rails. So very important points when you're thinking about this. And you really have to think about with that why the end user. We wouldn't want to take away someone's benefits based on AI that is not 100% accurate. It could make a mistake. And when we start talking about larger data, when we get into the billions of rows of data and the tens of millions of individuals, even a small false positive or false negative rate means a lot of people. So it really has human impact. So getting that human in the loop, a human at the helm, making sure that we're understanding the why and continuing to evaluate that over time is so extremely important in the public sector, and making sure that you know what this is going to do and what those potential impacts are going to be. I think it's really important by having these third parties that are involved that have not been part of the development that can go in and kick the tires on it and beat it up. This is called red teaming. So you get a group of folks that can go that weren't involved in development and they try to break it, not nefariously, but they try to make it come up with these things that are illusions, they're hallucinations. Because AI likes to hallucinate. It's trying to give you the most complete answer, but it's not always giving you the correct answer. So there'll be things that are in there if you're reading through it. It's like, oh, yeah, that's not right. I mean, it's a great thing. So I did this for myself when I was generating a resume. I was like, go out and generate a professional resume for the chief data officer of Indiana, Josh Martin. And it came back with a really good resume that's laid out. And I'm looking through it, and it guessed my email. It was close, but it was wrong. It added a bunch of extra things in there that would have been great if I actually had done those things, but they were fallacies. So it's, there's things where you can bring AI in and explore it and help generate those ideas, help it be creative, or containerize something in a way that people know what the AI is trying to do, what the why is, and they're aware that it's AI that is doing it, and they're comfortable with that, and they're going to opt into that solution. So, there's really responsible ways to go and do AI, but I mean, especially in the government and the public sector space, ethics is a huge deal, and we haven't had, uh, you know, professional AI ethical folks trained that are working in state government. It wasn't part of academia and higher education 20 years ago or 10 years ago. It's becoming an emerging need. The same as data science is starting to become even an emerging need. And we're seeing programs pop up at different universities to teach data science, which, by the way, used to be called applied statistics. So it's not a huge new realm that's coming out, but uh, we're still catching up because the technology is moving faster, and we need to understand how it's moving. And people like Sash, who are working on understanding what is going on and trying to keep on the front edge of it, and making people aware of what it can do and what it can't do. It can help you brainstorm, it can help you generate ideas, it can't apply for jobs for you. I mean, it can, but you shouldn't let it do that. It can't write an email to your boss. That could be very problematic. It can write a really interesting poem. It can tell jokes really well. But there's certain things that are just challenges that it's not there yet. It's continuing to evolve. It's going to continue to get better. But from my experience is you got to get your hands on it to understand it. I've been lucky enough to come up through the state organization, have a lot of experience working with numerous different agencies that provide a lot of different services, understanding the systems that they work with as part of their day-to-day operations, and having great exposure to the different data that we have from across all the state organizations. So having a good background in that data is like a really great first step as you look at how are we going to use it. There's been a lot of challenges using administrative data because the systems were implemented when there wasn't a time we were thinking about that secondary use and that value of data. So the IT folks are looking at, does the widget maker make widgets? Does the transaction happen as it should? And if the answer is yes, that's good enough. But it doesn't think so much about how that data is going to be used in the future or what the potential is, because that wasn't that important 10 years ago or 15 years ago. It's become much more important now, and you're seeing much more data professionals that are getting in there. So folks that have a really good opportunity to work with this data and understand the data, that can understand what these AI tools are trying to do under the hood, and if it's applicable to the data that you have, and having that why. Are we at a level of readiness that we can implement an AI that is going to do work on benefits determinations? I would say our data is not there. Our expertise is not there. Our data governance is not there. We don't have all the right, technical talent on the state payroll to go and do some of those things. We can go through those, very already pre-programmed steps. The yes, no, the inputs are very clean. But beyond that, we're still a long ways off, and we need to get that foundational data cleaned up. Or at least get a good understanding of it and start thinking about what is the new data that we need to be thinking about bringing in. How can we bring those actual people who are going to be affected by it into the conversation so that we understand it better. We understand what the needs are. We understand what the outcomes are going to be, rather than, just listening to this vendor that comes in and they say, hey, we have this AI model and it's going to reduce your fraud by 20%, or it's going to reduce recidivism by at least 50%. Um, and you pay a lot of money up front, you sign on the dotted line, and then you evaluate it way after the fact, and you're like, yeah, that wasn't any better than flipping a coin. um, those things are definitely out there. So being able to understand, the readiness of an organization, the readiness of a program in terms of taking on an AI project. What type of AI project should that be? Should it be an efficiency project, or should it be a growth type of project? Um, those are really important considerations that need to happen along the way. And there's great potential. There's really great potential as long as you understand the limitations. There's definitely things that you don't want to do, like generating emails for your boss, creating other emails that have the wrong tone. But there's things that you can do to help improve that AI, especially if it's for your individual use. You can continue to help it learn what you're looking for. You can give it instructions and content up front, saying, hey, this is really the tone I'm looking for. This is the expertise I'm looking for. And this is kind of the outcomes that I'm looking for. But you have to keep looking at what that output is and see if it's getting to what you really need. But the world's going to keep improving. We have all of these machine learning things that are really getting tuned up. We have tons of great algorithms out there that we can use for doing different things. We can create images like astronauts on a horse on the moon, which I love, by the way, and other things like that. There's a lot of potential there. Identification of things, character recognition has been around for quite a long time. We use it in a lot of spaces, especially with like paper forms that come in that people have handwritten on, to translate that into actual data, rather than being handwritten paper forms. But that still has opportunities to improve. So it's really looking at a lot of things, thinking about what's the application, what's the why, do we have the necessary things to actually achieve that? Do we have the expertise and folks on the payroll, that are on our side that can work with a vendor and call BS, or understand, what the algorithms that they're doing, under the hood? What's their implementation? Have they tested different models? How did they determine what model they were going to use? A lot of these models are commonly used, like k-means clustering, very commonly used in a lot of different places, to do persona generation. So basically, you say, how many categories do I want? That's K. Um, and it goes and it looks at all this different data, and you tell it what's the important artifact that you're looking for, and it groups people based on that. And they call that a persona, a group. Is that group good or bad? I don't know. How did you determine K? How many groups do you want? Trial and error, just to see what it is. So there's things that you have to be able to ask along the way to figure out, what is actually happening here, and getting more talent in government. And we're seeing a push at the federal level on this as well, to have chief data officers, to have chief analytical AI officers, they have chief statisticians. You have folks that are able to question things, to look at these things, because the folks on the outside that are hyping this and selling it, and the sales folks, uh, they're going to keep hyping it and they're going to keep selling it, and it's going to continue to be a challenge, of the effectiveness of it, and they can put up a really good case based on what their predetermined data is, what their showcase model is of how it's going to do things, and how they can do all these amazing things, and just sign on the dotted line there. Just make sure release that PO. But when it comes to putting it into practice, many times in the current state that we're in now, you're not going to see those results that you're really being promised. So kudos to you, Sayesh, for bringing that up, being really brave on that point. I recommend all you guys pick up this book. It's amazing. Do it. Mine came here recently, and I've just started getting into it. So it's incredible what you're putting in there. I think you're touching on on a subject that's a lot of people aren't willing or ready to step into because it is big folks like Microsoft and AWS and Salesforce and you name it out there that are already injecting AI into their products that you're calling out. So kudos to you, man. You're one of the good guys that we need on this side to help us start thinking about these things.
And so are you, Josh. It's really great to hear all the work you're doing and your team is doing. And so, yeah, I'd love to get into Q&A now, and I see some of the questions coming in, so keep those coming. We'll get through as many as we can, so we want to see what you're interested in. But Josh, I wanted to start with a question for you of if you could give us a little bit of thought on the process that you and others in Indiana went through to develop the AI use by state agency guidance. And you mentioned the NIST AI risk management framework as one of kind of something you could point to. So I'd love to hear a little bit more about the process there. And then why did you choose the NIST AI risk management framework as a point of reference?
Yeah. So the chief privacy officer for the state, Ted Cotterill, who writes a ton of our policies, is really focused on this, especially from the privacy standpoint. Really leaned in to take the lead on this from the data part. Our Office of Technology, who is one of our sister organizations we work very closely with, is handling it more on the technical and security front. But on the data usage part, that really falls into our house as it's a data governance and a data quality issue. So part of teeing that up was we knew it had to be a living document because it's moving so quickly. There's more things that are coming out all the time. And I don't have enough staff to continue to investigate and keep the fingers on the pulse of everything that's moving. So looking to an organization like NIST, who has an incredible reputation for the work that they're doing, they're continuing to improve and evolve and push this information out there. They're a credible organization. That saves us the time from having to try to do all of that on our own, which we know we won't do very well. But the other thing that we did is this was an incredible collaborative process for developing this. We sent it out to all the other agencies to get their feedback. We got incredible feedback. We implemented almost all of that feedback as we developed it to make sure it's going to be a policy that can work for all, and making sure it's going to be something that is going to be valuable and something that's not going to stymie innovation or slow down things or be a roadblock, but it's going to be an enabler to make sure that these type of projects can be successful and that we don't end up in the New York Times or any other news story at the top of the fold saying, hey, these guys did bad things with AI. We don't want to be on the newspaper for that. And we really don't want people to know, hey, this is AI that's achieving it. We're not going to go out and toot our horn too much on that. We just want better citizen services. And if AI can be a part of it, that's great. But we have to have guardrails. And guardrails are important to make sure that we keep our focus on what our job is, and the importance of equity, making sure we're ethically doing these things because of the right way. So I also have on my staff my deputy general counsel, who is the former state ethics director. So we were able to bring her over and bring her on, and she had done ethics for a long time. So we have an ethicist on the payroll who is thinking about these things. And we've gone out and we've got agencies trained in privacy through the IAPP. We're trying to build that knowledge up, but collaborative policymaking is very important, especially in these fast moving spaces, because you can't create it in a silo. It takes a team. It takes buy-in. So that was one of the main things that we looked at. And this was a very common sense approach. And if something better comes out, we're going to revise the policy and we're going to use something better. And as we're learning, we're going to revise the policy and we're going to learn and create better policy. So those are the key things and the key focus in that policy area.
I love that. Yeah, collaboration. All these different agencies have needs and inputs and expertise to bring to bear. Love that. Thank you, Josh, for giving us a little bit more insight into that process. Sayesh, I wanted to go back to one of the points you made. It came up a little bit when you were talking about sepsis prediction, actually, is like when the data scientists at the actual hospital is being used were involved, they had a better outcome, right? Like they were using it in the exact setting that it was being deployed in. So can you tell us a little bit about how about the importance of like testing AI systems under a real world condition or the condition you intend to use it in, how that might differ from testing under other settings, and then how could state and local governments implement these principles when they're using AI systems?
Absolutely. Yeah, that's a great question. So I think one of the downsides of this approach that we've adopted to AI, which is learning from data, is that if you have bad data, then you'll have a bad model. And so in case you're sort of, it does not even like need to be actively bad. Like in the case of the sepsis prediction tool, let's say you train this model on data from like hospitals in New Jersey, and you're deploying these in hospitals in New York. There might be like dozens of small differences just between these two states. In fact, there might be differences just between different hospital systems in terms of which ICD codes they use. That's the code that's used to classify a disease, in terms of what practices the physicians have, and so on. And so these small differences in the initial data set can compound to large differences in the downstream quality. So you might not think that two different like physicians in two different states using slightly different techniques would be picked up by a model, but that's in fact exactly what happens. And so it turns out that not only do you need data that's sort of representative of a situation, so you want data from actual hospitals rather than sort of medical schools or something, but you also need data from the exact types of hospitals where you're evaluating the sepsis tool or planning to deploy it. And in addition, like you also need to take care that this sort of happens over time. So hospital practices change, doctors change, and so on. And so what you really need to be doing is to look out for these changes and to keep training the model on newer and newer data sets, just to make sure that you're sort of not creating a model in 2024, which would have been a great model to deploy in 2018, but not really a good model anymore. So I think these principles hold more generally as well for cities and states that are deploying AI, is to always train on data that's as close to the real world as possible. And more importantly, to keep evaluating the model on that real world data to make sure it's doing well. And also to make sure that you're aware of performance changing over time, because the patterns and the real world changes over time as well.
I like that. That's definitely a theme both you and Josh raised. Checking in, making sure it's working the way it's expected in each of your scenarios. Wonderful. So, okay, we have another question. How can one person in an organization raise questions about AI to stop inappropriate uses of AI? I don't know who wants to take that. That's that's a big one.
I'll jump in there. If you have an inappropriate use of AI, you're already behind the eight ball. There's I said so many examples that you can take to put in front of those folks to say, hey, caution, don't listen to the sales folks, don't listen to the snake oil. There are things that we need to consider about this before we end up at the top of the fold of the newspaper because we made a false assumption. So making sure that your organization is in tune, that they have the data proficiency, the literacy, the understanding of what they're talking about, because too many folks, when they get to the top end of organizations, that they have this decision making authority, and they rely more on external vendors and what they're telling them and blindly trusting that can happen, rather than understanding and asking the hard questions about how it actually works, how it's been tested, and how you can do a POC before you spend several $1,000,000 on things to make sure that it's right in a controlled environment. So making sure that there is a good policy, a good practice, understanding those pitfalls and putting that up there. And maybe it's going up, if you're just one person, and saying, hey, I'm really concerned about this. I think we need some good policies and procedures, and we need to look at some of these best practices. We need to do this in a more formalized way rather than just the wild, wild west shooting from the hip. So let's start there. Another great book to pick up that is Sol Rashidi's book on AI. And everything that she's learned around the way. It has a great framework in there that's very easy in business minded focuses. But there's too many people that are overly confident in their ability to make decisions on technology, that the actual decision making around that technology that they make is nowhere near as good as what they think. So they've got this overconfidence that they know what they're doing, and yeah, it's technology, and I'm a technology person, but they don't really have the tuning that's necessary, and the knowledge and continuous learning that's necessary to make the best decision.
So I'll follow up on that. Thank you, Josh. I think another context that's been put in the chat is like organizations, including local and state governments, that are under pressure to make things efficient. And so AI is very appealing. So I'm wondering if both of you have thoughts on like, you mentioned some examples, both of you, but if you want to share any more of where can it be most useful for government operations? What are your thoughts on the best use cases here?
Yeah, that's a fantastic question. So I think some of these use cases have to be like the sorts of opt-in citizen services use cases that Josh just mentioned. So I think as far as I've seen these examples play out, in most cases, when you're trying to predict these outcomes, you can either be doing it for austerity or for like sort of reducing costs, or you can be doing it for providing benefits or making sure citizens are well informed and so on. And the cost of misfires for both of these are drastically different. So if you're sort of cutting benefits or putting someone in jail based on a wrong prediction, that outcome is very, very different compared to if you sort of suggest that someone takes an online course in a particular domain and it doesn't end up helping them out. And I think when we are looking at allocating benefits, when we're looking at sort of helping people out, I think the stakes are a bit less consequential, I would say, as opposed to when we're allocating burdens or you're asking someone to pay tens of thousands of dollars back, or you're asking people to sort of be put behind the bars.
So almost like a risk tiering, thinking through which have the highest impacts on people's lives.
Exactly.
Great. Josh, do you have thoughts of cases where you actually shared some in your own life that were helpful for you. So do you have thoughts you want to share that with everyone?
Yeah, it's really good for content generation. It's really good for brainstorming. It can be really good to help you get started. We've used it in some of the initial data governance work we've been doing in terms of documentation. Because if you say, hey, you need a data strategy, what does that mean to different people? For some people, that means you hire one of the big four and they create you either a huge slide deck or a very large document that goes and sits on a desk and collects dust. For others like me, I like something short, sweet, to the point that people can understand and that is actionable. So our state data strategy is the highest level, the most broad directional place that we're going as a state, which is, one of my jobs as the chief data officer is to set that transparency and analytics master planning and to help with that data quality work, which starts with governance.
Mm-hmm.
So setting those highest level things, but how do you start drafting one of those? You open Word and you look at it for a while, and then you write some things down and you do some bullets. Well, why don't you just go out and say, give me an example, start this up. Give me an example of a good data strategy. It'll come up with it. Now tune it towards government or a public sector thing, and it will come up with some more information. So you can actually get a start because it's so much easier to start from a document that's already there and tune it to what you need with your own knowledge. Rather than just trying to start from scratch. So it can really lower the time to help with that ideation to get the ball rolling on things. Summarizing long documents, telling you the most key points to look at, looking at concerns with different things. And there's a lot of applicable ways to use it. But you also have to keep those cautions in mind. And many of the applicable ways to use it are not putting out your own government data. Don't dump your data. Don't dump your code out there to these generative AI things if you're in the government space, because it's a huge risk right now. And your CISO will come and chase you down, and he will beat you senseless until you decide to resign. I have a great relationship with my CISO, and we go back and forth a lot on the opportunities, and we have to know that it's very secure, but we know that there has to be innovation and looking at these different things. But my biggest advice out there go out and use it in your personal life. I've used it for helping, with resume development. I've used it with helping with formatting documents, making them more, easy to read. I've taken and copied and pasted stuff from a bunch of different websites and just jumped it into a Word document of here's all the different things that I've been, involved in, and articles I've been cited, podcasts, other things that I've done like this. And the formats are all over the place because I just copy paste, dragged it over. Not a ton of other information in there. And then you upload those into an AI model and say, can you fix this, please? And it does it in a matter of seconds. So rather than me going through and trying to format and make everything look nice and everything, and it also was really good at adding very little summary information about each. So I was really, really pleased with that. But yeah, just going out and getting your hands on it and doing things that are applicable to you is going to help you get familiar with what's out there, and it's going to help you get familiar with identifying hallucinations, identifying things that are going to make better inputs. There's going to be better system instructions, developing, better prompts. It's all a learning experience, and it's even if your first response from the AI is there, looking for those improvements that you can ask AI, get better, get better. Now tune it to this, get better, add some of this in, and it's really good at that and generating things very quickly.
Yeah, absolutely. And there's a little bit of human training too, and best ways to be using AI and how you can get out of it what you want. We have a question about how many other states have chief data officers and AI use policies. And it's okay if you don't know this, Joshua, but if you want to comment on that generally, even if you don't know the exact number.
I'm not sure on the exact number of current formalized policies. Some states are taking different approaches on things. Some are creating task forces. Some are, either internal or external, or they're pulling things together. They're taking, their own approach, the way they solve problems. But I believe we're up to 38 chief data officers or similar roles across the different states. So Indiana was number 7 to have a chief data officer. But there's only, I think, 3, maybe 4 of us now that are actually not in the IT organization. So I'm in the management and budget organization. So data is closer to business than it is the IT system. And the IT folks have enough on their plate already with worrying about cybersecurity, the network, the data center, enterprise applications, the major negotiations of said enterprise applications. They have a lot. My CIO has a ton on his plate. So when he goes and he sees something, he's like, that's a governance thing that needs to go to Josh. So I get kicked a lot of things because we have this great hand in glove relationship about how we can both evaluate things more efficiently and more effectively. So it's a growing role, and it's not just in the public sector. It's in the private sector as well. But looking at the federal level, it was the Foundations for Evidence-Based Practice Making of 2018, which passed in 2019, that set out the framework for the federal government to create CDOs. They were mandated to create these CDOs. They have a CDO network now. They have chief statistical officers. Now they have to also designate chief AI officers, which some of those are CDOs and some of those are going to be others. So they're growing that capacity too. And now they're starting to work with some of us in the states to share knowledge. So it's going to keep evolving, and it's going to grow faster. There's a huge need for not IT coding professionals, but people that can understand work and have the data literacy and proficiency and can apply that to the business and can understand the risks involved with that and the rewards.
Absolutely. Thank you, Josh. I'm going to there's a link that an article that came out recently, I think GovTech's like tracking the different AI policies, big picture stuff. So we'll put that in the chat. And we have about 5 minutes left. So I'm going to do a quick reminder about the survey and put a resource in the chat. And then I'm going to ask each of you if you have like a final thought, like a 1 minute, one thing you want to leave our audience with before we end. So let me put a plug in. That's the AI policy tracker, but let me put a plug in for responding to our survey at the end of this webinar for all of you. We really value your feedback, and it does very much help us know what types of information needs are most helpful for folks who are attending these webinars. So thank you. Joanna has put the link in the chat. So please go to that. It'll also pop up at the end of the webinar. And I want to say that if you have questions for us, we're always happy to hear from you. I'm sticking our email in the chat. And last but not least, I will put our website, which has more resources, also in the chat. Okay, and with that, I will ask Sayesh, do you have a parting thought or one more idea you want to leave our audience with?
Yeah, absolutely. I mean, I saw this very interesting question in the Q&A, so maybe I can leave with that, which is,
Please.
what do we think the shelf life of our comments is? I think it's right to be skeptical of skepticism about AI. In the last decade, we've made a lot of progress. But fundamentally, the things that we are talking about when we're saying predictions are hard are not about AI. They're about the social phenomena that we are trying to predict. So irrespective of whether AI gets better at generating content and generating all sorts of images and protein structures, and it's used in healthcare and so on, there are certain fundamental limits to how well we can predict the future. And so in some sense, when we're saying that predictive AI does not work, I think it's more a reflection of the underlying social phenomena rather than any limitation of AI. So it's not just that AI can't predict the future, it's that predicting the future is inherently hard. And so I think just keeping in mind the differences between the different types of things we're trying to do with AI can really go a long way. Like, how hard is it fundamentally to predict if someone will win a lottery ticket and their life would be completely changed? And how many of these events happen every single day in people's lives? And so I think just keeping that in mind and keeping in mind that generative AI and predictive AI are sort of trying to do very different things would be my sort of key takeaway.
Thank you so much, Ash, and thank you for just so clearly articulating these different technologies. It's never easy to take super technical topics and explain to folks like me in plain English. So thank you very much. Josh, do you have a parting thought you wanted to share with our audience?
Yeah, I think the big thing that you need to do is be skeptical and continue to ask questions. There's a lot of things that are out there, and if you just take the first thing, information is moving so quickly. We're consuming information as humans more rapidly than we ever have before, and a lot of people are just taking it as gospel. I mean, there's a question in the Q&A about, being concerned about deepfakes and other things like that. And the concern really isn't about the generation of those. They're going to continue to be generated. It's not something that we're going to be able to put that genie back in the bottle. But as human beings, we need to be able to verify. We need to do a little bit of research. We need to dig into. I have to tell my dad this on a regular basis. He'll post something. I was like, Dad, there is not a giant snapping turtle in Monroe Lake down the street here that's eating people. It's not there. You should know better. You were a farm boy. You grew up. You know there's not a snapping turtle of that size. I swim in that lake. I boat in that lake. There's no snapping turtle that's eating people down there. But if you're really interested in going to things, this is something that goes way back to when I was in high school. I won't even tell you how long ago that was, but go to this website called dhmo.org, and it talks about the dangers of dihydrogen monoxide. And look around there to the dangers of dihydrogen monoxide. It kills a ton of people every year. So trust but verify, read things, understand things, and ask more questions. Continue to learn. Curiosity is good. Verify. Improve your data literacy. We're being fed numerical things on a regular basis, especially in the media. Oh my gosh, there's been a 10% increase in crime, but there's no other number to rationalize it to. So, Sayesh, if I tell you that I'm going to give you 10% of the money in my pocket, is that the last thing that you want to know? I think he wants to know how much money is in my pocket so he can calculate what I'm going to give him. So there's always more than one number to look at. There's more things to be thinking about. So be curious, trust, verify. Make sure that you understand what are those things to look for. If it sounds fishy, it's probably fishy. If it doesn't sound like it's something realistic, like people eating cats and dogs, it's probably not real. So the misinformation war is going to be out there for a long time, and it's all of our responsibilities to make sure that we're doing our part in researching and validating and making sure that we're getting the best information and we're able to identify the misinformation along the way.
Thank you, Josh. Really appreciate you sharing your expertise and your experience in Indiana. And thank you both so much for all your insights, and thanks to the audience for joining today. So with that, we'll close it out. So thanks so much.
Thank you.
Thanks a lot, folks.